Hello students, this is Shyam Sundar Agarwal and we are going to discuss further our Python programming lab. So I hope that by viewing the previous videos, all of you have installed this Anaconda Navigator and launched this Spider. I have also told in previous video that if you are not able to do this because of your old PC or old laptop, then you can also use online interpreter compiler websites, online GDB, etc. So I hope that you are now aware of those all things, and uh, we also launched the Spider, and I told you that in this manner it will look like. So you can write your interactive mode, you can use in interactive mode or command line mode here, and you can write your scripts here and can save them and execute them. So all those things we have already discussed in our previous videos, and we have also seen how to use the basic arithmetic operations and print command. So if you have not watched the previous videos, you first go and watch all those videos and prepare yourself for writing Python scripts. Today's discussion we will include keywords, identifiers, and variables and basic data types. So because I know that all of you have studied C programming, C++, so I know that you must be aware of keywords and identifiers. So first of all, I'll talk about keywords, and few things I will do intentionally so that you will be knowing that if you do in that manner, it will not work. So say if you want to see the keywords list of Python, then you can do it on command line like this. So what you'll write, you will write keywords. So first let me erase the previous variables. So all variables I remove. Now let us write here keywords dot kw list. That means kw means keyword list. So this is showing some error. So what you'll do, you will write import keyword. So after doing this, I'm pressed the enter, and you see that import keyword, it is imported. Now I will write keyword dot kw list. So here you see the list of keywords which are used in Python programming language. So this list you can also find in books, and here you can also see anytime by giving a command keyword dot kw list. So you can see here I have not used capital K, it is small k, and here also it is, and not keywords, it is only keyword. So if you use keywords, it will not work. So these are the various keywords. I'm not going to read it out, all of the keywords. You will come across these keywords when you write some small programs. So many of the keywords you already know, like this for. In C programming, it was also there, if, so, else, and there are many new also. So how to use them, discontinue you are aware of, break you are aware of. So when we'll write small programs, you will come across them. By definition, if you want to know again what is the keyword, then keywords are reserved words for any programming language. They have their predefined specific meaning for the compiler or the interpreter. So you cannot use them for your own purpose, because they have well-defined, predefined purpose. So they are the reserved words of a programming language. Then we talk about identifiers. So identifier, by definition, you know, because you have learned in other programming languages also, identifiers are names given to variables by the programmer, given to variables, and comma functions also. You also define function name. So functions, structures, etc. So these are the etc. by the programmer. So these are the words, these are the things which are defined by the programmer. Like if I write something variable integer x, then this x is called an identifier because its name is given by me. So as a programmer, when I give some name, then these are called identifiers. So names given to the variables, functions, structures, etc. by the programmer are called identifiers. So in this programming language also there are identifiers, and their naming rules are same as that of C programming. So when you name an identifier in Python, like C programming, you can use only digits, these capital letters, small letters, and underscore. So you cannot use any other special character like hash and uh, these spaces, etc. So the permissible characters are these. So say if for practice, if I again ask you, like say if I keep a name like this F123 underscore, then this is a valid identifier. So because it is using only capital letter and these digits and this underscore. But if I say that uh, the other rule is, as in C programming, that it must start only with underscore. So you can start with only, you cannot start with digit, and these things can be used for starting. So I change the say this. So you can start the name with this only. So say if I say that 9F23 underscore J, then this is invalid identifier. You cannot keep this name because this starts with a digit. So if I do this, then this is a valid name. Now say this is valid or not, AB space K. So this is invalid because there we are using space over here, which is not permitted. So I don't want to talk much about identifiers because you have many times studied them in other programming languages also, and they are the same. And C programming rules are also applicable here in Python programming for identifiers. So these are the identifiers. Now let us see the variable names you will give, but there will be a difference in C programming and Python programming. Say here I tell you that if in C programming I write this int x equals to 100, say for example, then what happens in memory, some few bytes are allocated, and those bytes say this is my memory, then some few bytes I allocated here, uh, and these bytes, this variable is created, this will be named as x. So whenever I use x, these memory location only will be used. This memory location will only be used because this x is bounded with this memory location. So this x we will call as a tag of variable. So this tag is attached with this memory location in C programming. So what will happen if I write like this? Say I also have some int y and equals to x. Then what will happen? Because we are declaring other variable int y, so it will create a variable y in some at some other location in memory. So this is y. So this is memory location x, this is memory location y, and you are telling that y equals to x. So this 100 will be copied over here. This 100 will be copied over here. I'm talking about C programming. In the C programming, this will happen. But in Python, what it how it happens that when I write x equals to 100, see this int is not required in Python. So I write x equals to 100. Then what happens? An object is created with value 100, or this object is created. So say this object is created over here. So this object is created here. The tag x belongs to this object. The tag x belongs to this object. So when I write this y equals to x, a new tag y also belongs to this object. Also belongs to this object. It means if I write 100 and then x equals to 100, then one object 100 is created, and if I write y equals to x, then the y tag is also given to the same object which is existing already. So both an x and y have this memory only. So what will happen if I write now x equals to 200? Then y's value will be here because y is tagged over here, and one new object is created of value 200 and x will point to it. That means x is tagged to it. So x value will be 100. So memory location x does not keep this memory location. X will leave this memory location. X will be tagged on this memory location. So this is a big difference in operation of these variables. Say again, I'm in C programming. If this is integer x, so say this is integer y, then this integer x, this belongs to say this memory location x, and this y belongs to this memory location. Then if I write this x equals to 100, 100 will be stored here because this is x. When I write y equals to x, a new 100 is stored here because this is y location. So on y location, 100 is again this stored because value of x is 100. Then if I write x equals to 200, then what will happen? This memory location is altered. This memory location is altered. So this memory location is altered, but x is yet tagged to this memory location. In case of Python, when I write x equals to 100, this object 100 is created. When I write y equals to x, y is tagged to the same memory location. When I write x equals to 200, x is tagged to a new object 200 over here. So in this way, they are operationally little bit different. So here we check it. See, in C++ languages, they are called strongly typed language. So I will write here C++ are strongly typed, means when you say integer x, so that x variable or x tag, whatever call it, that will be uh, attached to the memory location. So C++ are strongly typed. So strongly typed, when I say, means that when I write this integer x, then that x is attached to a particular memory location, and if x is integer, it will remain integer throughout the program. But in Python, when you change the object uh, tag like x equals to 100 and then you write x equals to 100.5, then you are tagging x to other object which is of floating point type. So this Python is not strongly typed language. It is not a strongly typed language. Your type of x will change. So let us see here how it happens in Spider. Say I write here x equals to 10, and then you see, you keep watching, how can I see its variable type. So this x is now, it is telling integer type. So I write type and in bracket x, so it will tell me what is type of x. So type of x is int. Now you see, if I write x equals to 20.57 or 56, then again I write type of x, then what it will return? So it will return float, means type of x is changed. So there was an object which was created 10 and tag was put on it x. Then another object was created and x tag put on it. So x is not a particular memory location. X is not by force integer or float. It keeps changing depending upon the object on which you put this tag. So I hope that you are getting this point and this difference in operation of C and C++ and this Python programming. So uh, we also use word tag for this x instead of variable. So variable has a specific and fixed type, but here we say that this tag can be put on any type of object. So Python tag has no type. Its tag has no type. You can see here it has no type. Whenever you assign some value, it converts it changes its type. So you do something and see here. See, x equals to say 300, and then y equals to x. So you are doing these two things. X equals to 300 and y equals to x. So let me first check their types. So type of say x. So type of x is integer. Let us check type of y. So type of y is also integer. Now let us see their ID. So object ID. So when I write x equals to 300 in Python, an object 300 is created and tag x is put on that object. So that object has some ID. Similarly, when I wrote this y equals to x, the y tag is also put on the same object. So let us see ID of x. So this is ID of x. Then what you see, there is some number, a big number. So that is internal ID of x. X means the tag x is attached to object 300. So ID is given like this. And then see if ID of y, what is ID of y? So is this same? Is this same? Yes, both of them are same. Means they are tagged, x and y are tagged to the same object. Therefore, their IDs are same. Now say, if I write this, x equals to say 67.50, then what will happen? X is not attached to some memory location or some data type. Now I'm assigning it a float. So this. Now you do ID of y and ID of x. So you will see that ID of x, now new ID is assigned to it. This ID is new one. This is not like this. But ID of y is same, means y is yet pointing or tagged to the value or object 300. So this 300, y is tagged yet there, but x tagging has been changed. X now is tagged to a new object 67.50. New object location or ID is this. So new object is tagged with x. So x have left it previous location. So it is location. It is not location wise variable. So it is not holding a particular location. So that I hope is enough to make you understand that what is the difference in these variable names when we give and what is strongly typed language like C, C++, and this is dynamic typing. So one word we used in features of Python, that is dynamic typing. So this is how you can understand what is dynamic typing. So type of x is changed over here when I assign some other value to it. So this is concept of dynamic typing. At the same time, you have also understood few things like using this type and this ID. So when there is an object, it has some ID, and uh, you put tag on it. So you can put multiple tag on it. When there is no tag on some object, then the garbage collector automatically remove that. So we also studied one feature which is called, like, let me show you here, that in previous classes uh, we have seen this. One is dynamic typing. So that I hope today is more clear to you, dynamic typing. And then is automatic memory management. So automatic memory management means you will say that I have created some object, right, by writing say like this x equals to 500. Then you assigned some y equals to x. So now this object 500 have two tags, x and y. But now if I write x equals to 10.2 and y equals to say 7.5, then what will happen? That x is now tagged to new object 10.2 and y is now tagged to new object 7.5. So what is the tag of 500? Nothing. Tag of 500 is not available. So it means that this 500 is object is not having any tag on it, so programmer cannot directly use it. So what will happen, that this will be called a garbage memory now, and it will be removed automatically. You need not take care of it by the uh, automatic memory management system of the uh, Python. So these are the few changes in the concepts of the variables which we declare. So I hope this will be helpful for you to understand. And then let us see that if I want to typecast. So typecast, you all understand. In C programming, you have typecast many a time. So typecast. So typecasting means that you are altering the type of some variable. So say if I have some x equals to 70, let us do there only in the command prompt of spider. So say if I have, let us clear all the variables first, then we'll do. So I am clearing now all the variables, remove the variables values. So say I write 78.24 x equals to this. So what will happen if I display x? So print and then x. So it will print this value 78.24. Now if I display the id of x, then so id of x, so there is some object 78.24 in memory and x is tagged to it. So id of x, it will tag will be depending upon on this object. So this is the id. Then if I write something like y equals to int x, so this is what I'm doing. I am typecasting x. So this will perform truncation. You know truncation. What is truncation? So truncation means you will drop the digits after decimal point. Maybe it is 78.9 or anything, but it will be dropped. So 78 will remain. So if you now watch the value of y, so print say y, uh, then it will print 78. And if you see id of y, then you see that this is different from this. So you can do like this. This is called forced typecasting. Forced means you are by force you are dropping the type of this. So you are making it int, and then it is assigned to y. So if you write y equals to x, y will become float type, because x is float, y will also become float. But you have typecast it. So in this manner, this happens like, but you can see more examples also, and you will, if you enjoy programming, you will be very happy to know a few things, small things like this. See, if I write this, z equals to say 2, and uh, let us say y equals to x. So y equals to x. Now you see id of z and id of y. So are they different objects, or they? Oh, sorry, this is not x. This is z. So let us again clear and then do this. So what I'm you be clear what I'm telling you. So say z equals to 2 and y equals to z. So if you see id of y and z, you will see they are same because they are uh, tagged to the same objects. So id of this y I have seen and z, let us see. So y and z are tagged to the same object. Same object they are tagged, thereby their IDs are same. Now you write here something like z equals to z plus 2. So what will happen? Z will become 4. So this is, now you print z. So z is 4. What is id of z? Let us see. Id of z. So id of z is not this. It means Z was not attached to any memory location. Z was tagged to 2, and when you wrote this Z equals to Z plus 2, a new object 4 is created, and Z is tagged to it. So Z is now tagged to another memory location which is holding an object with value 4. And what happened to Z? Y, ID of Y, this is the same. It means 2 is there in the memory somewhere, which we call object 2. There were two tags Z and Y on it. Initially it was Z, then it was Y. So there are two tags on Z. When I write this, a new object is created somewhere else in the memory and tag Z is put on it. So this 4 is another object. 2 is not destroyed or overwritten. So there is nothing like overwriting and all. A new object is created in this case. So this is how there is bit difference in internal assignment of variable to memory location. So you can understand this, so that sometimes if you see some different kind of results in from C programming, you can understand why it is behaving like that. So it is it. Then further, we can discuss basic data types. Like there are many data types in C, this Python programming, which are new to you, but data types. So we will start with numbers. So numbers are int, float, and floating point numbers, integer numbers. Then new type is complex numbers. So complex numbers, and then bool type of number. That means they are not in fact numbers. They are 0 and 1. So 0 or 1. So we use keyword true or false. So these are two output for bool type of variables. So in Python, there is no limit for the integer range. Like in 3.x, actually there is no limit and all. Like in C programming, you have limit on integer type of data, and their size is fixed and all. So there is nothing like this. In 2.x, it is said that there 2 to the power 32 is the limit on integer, but in 2 we are using 3.x of Python, so there is no limit. So there are many data types, as I have said, but out of those many, we are going to only discuss these numbers today. So what are number type of data types? So number type of data type are integer, floating point numbers, complex numbers, bool, etc. So let us see and let us understand how to use them. So here in on command line, I'm writing like this. So this is again, if I take first of all, let me clear all the variables. X equals to 10, and you see its type. So type of X, so it is integer. Say Y equals to 2.34, and see its type. So you will see its type is float. So Y, so its type is float. So these are number types. So under number type category, we are seeing integer and float. Now if I write like this, see some Z equals to false. So this false, let us write in a small letter also, so that you will understand that this is not right way of writing. Like this is syntax error. So you will write capital F. So say Z equals to false, FALSE. Now you will not put any quote on false, because this is in this is a well-defined word for your Python interpreter, and it has certain meaning. So it is false. Now you print Z. Then this print Z. not printing. Z equals to false. Uh, Most recent call. Z is not okay. It is about capital Z and small z, because I have typed here capital Z and I'm printing this small z. That's why this is the problem of this error. So errors must always be there. It must appear so that you will understand. So this is false. And if you see type of this type of capital Z, then you will see it is bool. Bool for boolean. So B is small here, you can note. So it is type is bool. So true and false, T capital, F capital. So these are two values which a bool variable can take. So you need not tell bool type of variable. You only assign the value, it will take. Now let us see few things about complex numbers. So in Python, say 2 plus 3j, if I write, it is a complex number. So it is kept in brackets. So 2 plus 3j. So this represents a complex number. So what are complex number? I'm not going to teach you mathematics again of 12th standard. You all know. So complex number is this. So you can also create a complex number like this, like z equals to, or small z it is. So 2 plus 3j. So this is this. Now you display z. So this is this. If you see the type of z, what it will show? Complex. So C is small, complex. So complex is the type of Z. So there are many operations which you can apply on this, and you can also create a complex number by writing complex and in bracket. So that I'm also showing you. Say some A equals to, and I'm writing this complex, and in brackets I write 3 comma minus 4. So this is a complex number. It is number is created. So if I write A, it will show like this. This is a complex number 3 minus 4j. So by writing this complex and in brackets, I can create a complex number, or I can also create complex number like this. So this is a complex number, and if you see its type, it will show you complex. So complex. Now, if you want to see the real part of a complex number, only the real part. So if I take this A, for example, so what I can write A dot real. So A dot real will give you 3.0. So you can see here, real part is this. And if I write A dot imaginary IMAG, you please see it. Syntax is required to be remembered or memorized. IMG will not work. IMAG. So it is minus 4 for this A. So you can see it here. If you want to see the absolute value of a complex number, so ABS of A, then you will see here 5.0. So how to calculate value, absolute value? So if it is A plus B, then A plus BJ, B iota, then it will be A under root of A square plus B square. That is the absolute value of complex number. So you can see the absolute value of complex number. Similarly, if you write this conjugate, so conjugate, then see the syntax. So this is conjugate. Conjugate means the complex part sign is reverted. So this is how you can use complex numbers. So complex number declaration, you only need to assign value like 3 plus 5j, etc. Or you can write z equals to complex, and in bracket you can give 3 comma 5. You can calculate the conjugate anytime like this. You can calculate the x absolute like this. So in this way, you can use these things. These are the number type of number type data type in numbers. So this ABS is not only for complex, it is also for other numbers. So I have taken here minus 123.23, and then this is a floating type of object, and then I'm taking absolute value of it. So here it will change the sign. In case of complex number, absolute value is defined as, say if I have A plus iota B, then it will be A square plus B square whole under root. So that will be the value. So these are the uh, types of numbers: integer, float, complex, and bool type. So this is enough for today's discussion. In next class, we will discuss some more data types, um, which are specific to Python. So thanks for watching this, and I hope that you will practice it and uh, will memorize it by practicing, not by like mugging it up. You will practice, then you will automatically memorize all these things. Thank you very much.